Hi, good afternoon, all the students. I am Dr. Sudarshan Behra, working as an assistant professor in SR University, Warangal. Today, now we will discuss syntax analysis. This is comes under lecture 6. Let me share the PPT. In the previous class, we started discussion on syntax analysis, and this will go for 3-4 classes. It will, because this particular topic is little bigger comparing to other topic. Yes, in the previous class, we just started discussion on syntax analysis, and we just came to know what is syntax analysis and what is the role or the function of syntax analysis, right? And from there, we came to know that syntax analysis or the syntax analyzer is the second phase of compiler, which collects the tokens from the lexical analyzer, or ultimately you can say from the symbol table, okay? And it organize them as per the order it is specified, and again it impose a grammatical structure on them to see whether their organization is proper or not, to see whether the entire sentence is grammatically correct or not. Okay, for that it takes the help. It particularly use a specific grammar called as context free grammar. We will be knowing that in the next within the next 1 or 2 minutes. Okay, so up to here we covered. Now go for lecture 6. Under lecture 6, same thing will continue. Okay, we'll try to know more about the roles of syntax analysis or the syntax analyzer, and we'll be knowing about what is the context-free grammar, how it is used by the syntax analysis or by the syntax analyzer in order to check the validity of a sentence. Okay. So here you see one example already given. Okay, just what is the second step of this particular syntax analysis? The step one, it reads all the token. I mean, it collects all the tokens from the lexical analyzer. In step two, it impose on grammatical structure. You see, one grammar is given: e derive, e plus e, comma e derive id. That arrow mark is pronounced as derive. Okay, or in the form of, or you can read e is in the form of e plus e. Next one, E is in the form of ID. Okay. Or you can say E derive E plus E. And for the second one, you can say E derive ID. Okay. So that arrow mark indicates derive, or you may say, or you may realize it in the form of. Okay. The third step is it builds the parse tree. The syntax is correct. If the syntax is correct, the parser construct a parse tree. So if the syntax, if the sentence is, grammatically correct, then it produces a parse tree or a syntax tree as an output. Then it send that syntax tree or the parse tree to the next phase of the compiler, that is semantic analyzer. Okay, but it is not easy to say that it produce parse tree if the syntax is correct. It produce parse tree. It is not easy to say that. Rather, lot of steps involved. Okay, in between. Okay, that we will see. Okay, let us take one example here. In the C language, one example is given: A equals to B plus C. Okay, and for that, the corresponding parse tree, which is generated by the syntax analyzer, is A equals to, equal symbol is kept in the tree. Equal symbol is kept at the root, and A is the left child and plus is the right child. Again, that plus has two more children. One is B and C. How exactly it happens? Is it, can you draw it simply? No. Can you draw it in any order? No. So there is a procedure to derive this tree or to find out this tree. And the procedure is known as derivation. That we will be discussing next. Okay, after that, it also perform one more step. Okay, that is it detect the syntax error. Okay, if the syntax is correct, no doubt the it build the syntax tree. If the syntax is wrong, if the sentence is wrong, then what it does, it produce the error to the user. It says that the error is this is the syntax error. Okay, let us take one example. We are always writing int b. That is what? Int b semicolon. What is that? That means you declare a variable b which is of integer type. Okay, int space b semicolon. This is the variable you declare. The sentence is very correct. If you write b semicolon next int, now the question is the sentence is correct? No. But the instruments are same. The tokens are same. Previously int was there, now also int is there. B was there, now also B is there. Semicolon was there, now also semicolon is there. Space was there, now also space is there. Then where is the mistake? Mistake is in the arrangement, in the grammar. Okay, the grammar says that whenever you are declaring a variable, okay, first the data type of the variable must be appear. Okay, first the data type, whether it is int, float, double, or any other data type. Then the space, then the name of the variable or the name of the identifier, then termination symbol, that is semicolon. That is the right rule. But if you modify it, if you change them here and there, okay, no doubt the tokens are same. But if you place them here and there, then that is the mistake. Then the order of the construct, the syntax, okay, the order of the programming, construct, or the syntax of the programming construct. Syntax means what? Rules. Here, if you modify, the rule gets changed. If the rule gets changed, then definitely it will be grammatically ill. The sentence will be grammatically ill. Okay, so here it is not only checks the syntax is correct or correct and produce the syntax tree or the parse tree. Okay, other hand, it also checks if the where is the error, what is the error associated with the sentence. Okay, and if error is there, then simply it is send the error to the user for the corrective action. User in the sense the programmer. Okay, today you take your laptop, sit and do a basic C program, addition of two numbers, and you knowingly do that mistake. I'm telling you, you knowingly do the mistake. Okay, misformulate that line. Okay, variable declaration. Okay, and then what error will appear to you? From there you can understand. So without error, if you are writing a program in one attempt and you are getting output, then you are not aware of the error. That is what I am telling you. You do mistake. Do mistake and learn from that mistake so that you will be a perfect programmer. Okay, because you will have idea about the entire different types of error. What error will be there if I will do that mistake? What error will be there? So those who got error, they only seen the success. Without error, you cannot see the success. You cannot be a perfect programmer. Error you should do the mistake knowingly or unknowingly. You should know the types of error. Okay, fine. Let's move ahead. This is the working principle of syntax analyzer. What it does, it collect the tokens from the lexical analyzer, or ultimately you can say from the symbol table, because lexical analyzer keeps everything in symbol table. Okay, one by one, it consume one by one. Syntax analyzer consume them one by one, and then it makes them it places them in the original order as they appear. Okay, after that it impose one grammatical structure on them. Okay, the grammars Grammatical structure in the sense the grammar. Okay, the grammar is predefined. Try to understand. The grammar is predefined, and it is just to put a grammar, okay, and check the validity of the sentence. Okay, right. And if not, if the sentence is valid, it produces the parse tree. Otherwise, it will reject the sentence. Reject in the sense it produces the error. Okay. Next, the types of syntax analyzer. There are two types of syntax analyzer or parser, because I said the other name of syntax analyzer is parser. So there are two types of parser or two types of syntax analyzer. One is top-down parser and second one is bottom-up parser. Top-down parser is also called as top-down parsing. Okay, if you say top-down parsing also, that will be no mistake. Okay, top-down parsing, what it does, it is start from the root. Because the what is the output of syntax analyzer? The output of syntax analyzer is a tree, derivation tree or parse tree or syntax tree. So as the output, since the output is a tree, okay. So what it does, it as per the name suggests, it is start from the top. I mean from the root of the tree. Then once root is constructed, then it construct the interior node. Once interior node constructed, then it try to construct the leaf node. I mean the child. Okay. So it is start from the root and expand the grammar rules downwards. Okay, it start from the root and expand it towards the down. So that is why it is the parser is named as top down, because it start from top and comes to down. Okay, so that is why it is named as top down parsing or top down parser. On the other hand, the parser is called as bottom up parser. Okay, bottom up, as per the name suggests, it is start from the, it is first start constructing the leaf node, the child node of the tree. Then it construct the interior node. Then it construct the root node. Okay, so it start from bottom and goes towards up. Okay, it try to reach to the root. Okay, so that is why it is called as bottom up. It start from bottom and goes towards the root. Okay, so it is known as bottom up parser. The examples are for top-down parser, the examples are a recursive descent parser, and another one is predictive parser. These are the variants, actually, not example, you can say the variants. Top-down parser has two variants. One is a recursive descent parser, and another one is predictive parser. Okay? And on the other hand, the bottom-up parser has two variants. One is shift reduce parser, and the second one is left, LR parser. What is LR parser? I will tell you. Okay, I will tell you the full form. First L stand for left to right, R stand for rightmost derivation in reverse, and that is why it is called as left LR parser. Okay, we will be discussing that then. Okay, so before discussing top-down parser as well as bottom-up parser in depth, it is essential to know about the context-free grammar, because every time I told you, know how many times in a single statement, 2 3 times I'm repeating that context-free grammar. It uses a grammatical structure. I don't know what is that grammatical structure. What is that grammatical structure actually? What is that grammar? That grammar is called as context-free grammar. So before we delve into top-down parser, working principle of top-down parser, working principle of bottom-up parser, it is very essential to know what is context-free grammar, because both the parsers are using context-free grammar, okay, in order to check the validity of the sentence. So when that is the actual principle, then it is essential to know about the context-free grammar. Otherwise, we can't discuss about the parsing technique. Okay. Since parsing techniques are based on the grammar rules, let us first switch our discussion to the topic known as context-free grammar. So it is essential. Okay. So now let us resume. Let us pause this. Pause the discussion of types of syntax analyzer or parser here, and now switch to the topic context-free grammar. Let us understand what is context-free grammar, what are the components of context-free grammar, okay, and what is the derivation process associated with the context-free grammar, what are the types of derivation, and what are the different types of context-free grammar. Now, whether all the context-free grammar are utilized by both the top-down and bottom-up parsers, this is a question mark, okay, that need to be answered. So all these things we need to understand before we start discussion on top down parser as well as the principles of bottom up parser. Okay, so let us switch the topic here. So context free grammar. A context free grammar is normally used in the programming language. Okay, used in the programming language to test the syntactic validity, okay, of a sentence. What is syntactic validity? Syntactical validity of a sentence. What does it mean? Whether a sentence is grammatically or syntactically correct or not, because syntax is a set of rules. Similarly, grammar is also set of rules. Okay, the grammar rules are predefined, or the syntax rules are predefined. If you follow when speaking or writing, whether English or Hindi or Telugu or Oriya or some other language, if you follow the grammar, then definitely you can write perfect. Okay, you can write error free sentence. Similarly, you can speak error free sentence. If we won't follow grammar, so without grammar, everything will be mistake. Okay, due to lack of grammar, the sentence whatever we'll write or speak, that will be wrong. Okay, so here also same thing. Without the grammars are predefined, and there are many types of grammars. As there are normally 4 types of grammar, and one of the type is context free grammar. This is also called as a type 2 grammar. Okay, so this grammar is predefined to the compiler, and so that with the help of this grammar, compiler checks the validity of a sentence. Okay. Now, formally or mathematically, you try to know what is context-free grammar. A context-free grammar, in short called as CFG, is defined as a 4-tuple. Formally, it is defined as 4-tuple. That means it has 4 components, you can say. Okay. That is G equal to V sigma P S. Okay. What is G? G stand for the G represent the grammar. Then what is V? Capital V represent the finite set of variables or non-terminal symbols. This V is also called as non-terminal symbols or variables. So remember here, variables are equals to non-terminals. And always this variable and non-terminals are written in capital. Okay, as the grammar is concerned, context-free grammar is concerned, whenever you are writing a variable or a non-terminal, you must write them in capital letter. Then only one can easily understand, yes, it is a variable or it is a non-terminal. Okay, if you write in small letter, a time will come you will only confuse, and your answer will be wrong. Okay. So that is why it is exclusively mentioned that variables and non-terminals must be written in capital letter. Okay. Next, sigma, the second component or the second tuple. Sigma is a finite set of terminal symbols. Finite. Remember, previous one also finite. This finite means countable. You cannot take on infinite number of symbols. Okay, so it is a finite set. Set means there can be one, there can be multiple symbols. Okay, so that is why it is called as set. Finite set of terminal symbols. Terminals means input symbols. Okay, these terminal symbols are nothing but the terminal symbols of the input symbols are normally written using lowercase letter, small a, small b, small j. Okay, these is lowercase letters. Okay, all operators are also comes under terminals. Okay, any operator, plus, minus, division, modulus, any operator, or all special symbols are also comes under terminals. So terminals means lowercase letter, operators, special symbols. Okay, this all known as terminals. Okay, remember this. This is very important. Then what is P? P represent the finite set of production rules. So every grammar has some productions. Okay, from that productions only the grammar is identified. Okay, by seeing the type of production, you can easily identify the type of grammar. Okay, as I said, there are four types of grammars. Okay, but how they are vary from each other? They are vary from each other because of their production rules, nothing else. Okay, otherwise every grammar is a four tuple, but only they are vary from each other because of their production rules. Okay, I will discuss what is production rule. We will take one example on them to understand. Okay, then what is capital S? Capital S is the start symbol, and it is a part of non-terminal V. Okay, it is belongs to V. So capital S represent the start symbol. Start symbol means from where the I mean from where the grammar start. Okay, ultimately you can say from where the tree I mean building of tree starts. That is called as start symbol. Okay, when it produces a tree as an output, then this tree the tree start from the starting symbol of the grammar, that is S. And what is S? Is it a terminal or is it a non-terminal? It is a non-terminal because it is clearly mentioned. You see, S belongs to V, capital V. That means S is a part of capital V. Okay, is that clear? Very good. So four components. You can also, some authors are also mentioned VTPS. Here V is equals to this B variables. T means terminals. Here sigma is taken, but they are T. But both of them are having same role. Only the name is different. Because authors are different, they wrote a different textbook. Okay, so don't confuse. Here sigma, they are T, both of them are same. VTPS and B sigma PS, or some authors are also clearly mentioned is NTPS. What is N? N for non-terminals. Instead of V, they took NTPS. N for non-terminal, and T for terminal, P as it is for production rule, S represent the start symbol. Okay, so don't confuse. By you may read this from different sources like Google, ChatGPT, or from any other textbook. So don't confuse. Grammar has four parts, four components. Okay, and their the names are only the representation will be different, but their work is same. Here what work we will do in other authors book also the same work the we will do. Okay, maybe V is renamed by NTPS, but the meaning will be same and the work will be same. Okay, so don't confuse. Next, context-free grammar. As we are continuing that. Okay. Okay, what is the production rule? We covered three things here actually. One is V sigma PS. We came to know what is V. V must be V is non-terminal and it must be in capital. Then sigma, it is a set of terminals and it must be lowercase letter, special symbols or operators that represented by sigma. Okay, then S is the start symbol where the production actually start. or the grammar actually start. And while making tree, the building of tree also start from the start symbol of the grammar. Now only one thing left, that is P. P is the production rules. If I say P is the production rule, is that sufficient? No, not at all. We have to know it formally. We have to know it in depth. So this production rule has a specific format. Coming to context-free grammar, okay, the production rules of context-free grammar makes it different from other grammar. I think I am clear. The production rule of context-free grammar makes it different from other grammar. Okay, and what is the form of this of the production rule? Here, a derive, as I said, arrow mark means derive, or you may write a is in the form of alpha. So I can also read a derive alpha. Both of them are same. You can read a, or some students, particularly they have they knows from mathematical, as from the mathematical perspective, they likes to says that a tends to alpha. Some students I observe in my class, okay, and in my previous classes and colleges, they says, sir, a tends to alpha. Okay, whatever you say, you try to understand the meaning. Understanding is important. Derive tends to, in the form. Okay, that means arrow mark. You may put different name to the arrow mark, but try to understand the meaning of that. A is in the form of alpha, or a derive alpha. Where A means capital A. You can see the slide. Okay. So this where capital A is a single non-terminal. So in the format of the, or the production rule of the context-free grammar says that A must derive alpha, and A must present in the left hand side, alpha must be there in the right hand side, and A must be a non-terminal. Okay, A must be a non-terminal. Then what is alpha in the right hand side? Alpha can be a terminal, it can be a non-terminal, it can be a null string, or it can be any combination of terminal and non-terminal. Try to understand. Okay, try to understand. So this can be alpha can be a non-terminal, it can be a terminal, it can be a null string, or any combination of terminal and non-terminal. So that is why alpha belongs to V union sigma, clean closure of V union sigma. Clean closure means star. V union sigma. Okay, that means it is any combination. Any in the sense what? There may be no string. Any. There may be string of length 0. It may generate string of length 0. It may generate string of length 1. It may generate string of length 2. It may produce string of length 4, string of length 5, string of length n. Okay, so that is why it can be a null string. It can be a single terminal. It can be a single non-terminal, or it can be a one terminal followed by one non-terminal, or one terminal followed by two non-terminals, or two terminals followed by one non-terminal, or any random, there will be no ordering, random combination of them, and it may goes to n length of n. Okay, is that clear? So A derive alpha, where A must be single and A must be a non-terminal in the left hand side, and this alpha can be anything in the right hand side. Anything means I am very clear now. Okay, anything in the sense it can be a combination of, it can be a string of length 0, I mean null string. It can be a single non-terminal. It can be a single terminal. It can be any combination of them. Any order. There will be no ordering actually. You cannot say, sir, terminal will come first, next. No, not at all. You can put anyone anytime at any order. Okay. So that is your alpha. Now it is very clear. The format of the production rule is in this particular form: A derive alpha, where A is a non-terminal and alpha is any combination of terminal and non-terminal. Any combination. Any means, I mean, string of length 0 also comes under that. Okay. Any means there will be no calculation. You cannot say that is any means only one. Any means two strings of length 2. No. Okay. So any means anything. It can be string of length 0. It can be string of length 1. It can be string of length n. Okay. And any combination of them. Okay. Fine. I hope I'm clear. Next. What are the condition? This condition just now I said. No need to discuss this slide again, because it is showing that important condition of the production rule of a context program. The important condition is, it is very clearly mentioned, the left hand side LHS of a production rule must contain exactly one non-terminal symbol, as mentioned previously, capital A. And the right hand side can contain terminals, can contain non-terminals, can contain both of them. See, it is there, and can also contain empty string. As I said, empty string possible, any combination of them. The presence of both of them can be possible. Any order is possible. Only terminals can be there. Only non-terminals can also be there. Okay. When I said any combination, so it can be anything. Okay. Very good. No need to spend more time on this slide, as we discussed already. Next, context-free grammar example. Take an example of context-free grammar so that you can easily understand. So here the example is given that S derive, okay, S derive, small a followed by capital S followed by B. So capital S derive, small a followed by capital S followed by B. Here, capital S in both the side, left hand side as well as right hand side. Capital S represent the non-terminal. Okay. And AB represent the terminal symbols. Okay. Then if you divide this production, you'll have two parts. One is the left hand side, another one is right hand side. Then what is there in left hand side? The left hand side contains exactly yes. And what is there in the right hand side? The right hand side contains small a followed by capital S followed by B. Okay. So here another rule is also given, S derive epsilon. The second production rule. The first production rule says that S derive A, S, B. Second production rule says that S derive epsilon. Epsilon means strings of length 0, which is represented by epsilon. Okay. So here left hand side represent the capital S, right hand side represent a null string. These two things are given, taken as an example just to clear your doubts. The what rule we have gone through previous in the previous slide. Okay, that what will be there in the left hand side and what will be there in the right hand side. You can imagine from these two productions. Okay. A context-free grammar defines the rules. A context-free grammar defines the rules of language but merely defining the rules is not sufficient. We must also understand how these rules are applied step by step in order to produce valid string. Okay. So this context-free grammar is not only, it has 4 components, and because of some rules, it form the production, form its productions, right? But the question is, what exactly it does? What is the usefulness of these production rules? These productions or the production rules are used to check the syntactical validity of a sentence. And how exactly it happens? It happens through a particular process that is called as derivation. Then what is derivation? The process of generating string. The process of generating string from a given grammar is called as derivation. This is not simple. Let me modify it. The process of generating string from a given grammar by applying the procedure of substitution is called as a derivation. Okay. Now this is the finest statement. Now I will give you the example on this. What I said, the process of applying the process of generating strings from the context from a given grammar, grammar in the sense context free grammar, by applying certain substitution. Substitution means replacement. Okay, by applying certain substitutions or replacement is called as derivation. And this derivation, if I say like this, you cannot understand. I have to go through an example. Okay. And before that, let me tell you this derivation is of two types. One is leftmost derivation, in short called as LMD. Okay. Other one is rightmost derivation, in short called as RMD. Okay. So here you try to understand derivation explains the sequence of production rule application starting from the start symbol until the desired string is obtained. What I said, the process of getting or generating or obtaining the string, okay, starting from the start symbol of the grammar by applying sequence of substitution is called as derivation. Once derivations are understood, it becomes easier to represent the generation process using a graphical structure called as generation tree or derivation tree or parse tree or syntax tree. One tree has multiple names. Parse tree. Once you understood the process of derivation, okay, it will be easy to understand the string generation process, and it is easy to represent the process by using a graphical structure. That graphical structure is nothing but the tree. And what is the name of the tree? The name of the tree, the name of the tree is parse tree, also known as derivation tree, also known as syntax. Okay. So once you understood, yes, this is the path. If you want to go to Delhi from Warangal, okay, then how can you go? You can go by bus, you can go by flight, you can go by some other vehicles or some other transportation system. Okay, once you get your path, yes, in this way I can reach easily. Okay, then you just draw the path. That process of drawing is called as the understanding the generation process, understanding the transportation, understanding the route. Okay, whenever we are understanding a route, no, we are following map to check the route. What is the distance? What is the shortest way to reach to that destination? Okay, so we are capturing that in our mind. Okay, that map. And when starting, we are sometimes following that, recalling that until we reach to the destination. In the same way here. Once you understood what is the derivation process, you can easily understand how the string is generated. And you can easily just diagrammatically arrange them. That is called as a tree. Once you diagrammatically level them, that becomes a tree, and the tree is called as derivation tree or syntax tree or parse tree. That is the output of your syntax analysis. Okay, so this concept from the foundation for parsing technique is used in compiler design. So derivation and derivation tree, these are the most important concepts. Now let us understand what is a derivation with the help of an example. First, we will understand the type of derivation. Okay, derivation is the process of generating string by applying substitution. Once again, let me be clear. Derivation is the process of generating string from the start symbol of the grammar by applying multiple substitution. Okay, clear, very clear. The substitution process is not clear to you now until you get an example. Until you come across one or multiple examples, you cannot understand how exactly the substitution is happening. Okay, substitution is a technique which is applied under another technique known as derivation. Okay, or due to substitution, derivation is complete. Otherwise, it will not complete. That we need to understand. Yeah, what is derivation? We'll discuss from here in the next class. Okay. Let us stop it here. This example I'll explain in the next class, and we'll move forward. What is derivation? Then what are the different types of derivation here in the next slide? Then yeah, what is leftmost derivation? We'll take one example to understand that. Then what is rightmost derivation? We'll take another example to realize that. Then what is parse tree? How once derivation you understood, how the generation once you understood or once you clear that how parse tree how strings are generating, then you can automatically within no time you can draw it. Within no time you can draw it. So drawing parse tree is not a big job. Understanding the derivation is a little time taking. Okay. Then you can understand. Then one question I asked initially, whether all the grammars are acceptable or useful or applicable for top-down parser as well as bottom-up parser. Now the answer is no. Why no? Because some special kind of grammars are there known as ambiguous grammar. Okay, this type of grammars are not going to be digested by top-down parser, neither by bottom-up parser. Okay, and why? Because it has some demerits. Okay, that we have to discuss. Okay, so this is the top ambiguous grammar we'll discuss. Then transition to parsing. Then once this much is over, then we can switch our topic. We'll go back. Okay, we'll resume the topic what we left, that is resume the discussion on top-down parsing and bottom. Okay, so up to ambiguous grammar we must understood. Then only we can start discussion on top-down parser and bottom. Okay. So thank you. We'll start we'll start from the derivation process. I mean, we'll start discussion on the example of derivation. Okay, in the next class. Thank you for the day. I wish you all the best and have a nice day. Thank you.